This is the AIPMT 2010 question from vectors of two-dimensional motion. A very basic question. 6 vectors A to F have the magnitudes and direction as indicated in the diagram. Which of the following statements are true? So first of all, to solve this problem, we shall know that how do we add these vectors, two vectors graphically, right? Let me tell you. Two vectors, say this is A bar, this is B bar. We want to say A bar plus B bar graphically. So first we have to write one vector, draw one vector A bar. This is called head of the vector. This is called tip of the vector. If you want to add a vector B bar to that in such a way that we have to move this B parallelly. You can shift any vector parallelly. When you shift a vector parallelly, its magnitude remains same, its direction remains the same, and hence the vector also remains same, right? So I have to shift this vector parallelly this way, and then I have to shift that vector down this way. We have to move it this way and this way, so that the tail of the second vector joins the head of the first vector. This is what our B bar is. Then A bar plus B bar is the resultant of tail of the first vector joined to the head of the second vector. This becomes A bar plus B bar. This is how we add two vectors. That's a basic concept. Now let's have a look at the options given for you and check each of the options. First it was given like B bar plus C bar equal to F. So this is B bar. This is C bar. So what happens when you add B bar plus C bar? This is B bar. This is C bar when I have shifted parallelly. And then, sorry, I have to shift in such a way that, yeah, I want to say B bar plus C bar. To say that B bar plus C bar, I have to keep one vector as it is B bar. Join the tail of the second vector to the head of the first vector by moving it parallelly C bar. This will be the resultant of B bar plus C bar. But you don't have any of the options in the vectors in this way. So B bar plus C bar is particularly F bar. If you notice F bar is upward, but this has to be downward. So this is a wrong option. Similarly, check D bar plus C bar as F bar. See, this is D bar. This is C bar, right? Try to add both of them. This is a D bar, C bar. This is C bar. I have just shifted those vectors positions parallelly. Then this is what you are supposed to be resultant of that. But your F is not in this way. If you notice, F is not in this way, definitely not in this direction. So this is also wrong. Let us check D bar plus E bar. This is D bar. This is E bar. See, let me use another color. Yeah. This is D bar. And then I have to add E bar. E bar means I have to add the tail of the vector to the head of the first vector. This is like this way. E bar. Then resultant of the two vectors is a vector joining the tail of the first vector to the head of the second vector. This is how your resultant has to be. Look at your F bar. It is that way only. Look at that. Look at that. Your vector. Look here. Both are same. So this is the correct answer. That's how we have to get the answer. So obviously this is not going to be a right answer. But so how do you get to this answer? It's very simple that this is the graphical way of adding two vectors. We have to add in such a way that keep one vector as it is and then move the second vector in such a way that tail of the second vector is joined to the head of the first vector. Then the remaining tail and head are joined together, which gives an addition of the two vectors. That's a graphical way of adding the vectors. You have to use that concept to identify the answer, that d plus e equal to f. That's the answer. Thank you for watching.